Right, hello, welcome back to another video. So today we're going to be carrying on with our blueprint series, carrying on from where we left off last time. So if you remember, we made a blueprint, put a light inside it, and then we used some parameters to be able to edit that light directly in the editor on the instance of the blueprint, which is really powerful for building up tools, being able to sort of edit things live. So today we're going to be continuing with that, but we're going to be spawning some meshes inside the blueprint dynamically, taking that a little bit further, and we're going to get into some loops and some sort of programming. So, right, let's get started. So, new blueprint. Again, as I said last time, most of the time we're just dealing with active blueprints, and that's what we're going to be doing with here. And I'm going to call it mesh spawner, because that's what it's going to do. So I'm just going to drag that into the world, and then open up the blueprint editor. So we're still going to be working with construction script. We're still doing things on creation. We're still using this to sort of make things, so it's only a one-time construction script run, and we'll get onto event graphs eventually. So we could go in here and add a static mesh, and then set this. I'm going to be using the chair from the starter content, just as a mesh. And this would work. We'd add our mesh to our scene, but this isn't very dynamic, doesn't give us any flexibility to do anything else with it. So rather than adding our static mesh and components, I'm just going to delete that. And in the construction script, I'm going to do a node here called add static mesh component. And that's going to do the exact same thing. It's going to take our blueprint, going to run a construction script, add the static mesh component, and rather than add component here, it's going to add it on runtime. So here, static mesh, what do we want to add? Well, it's sm chair. And if I compile that, nothing happens up here. But if we look in the viewport, we've got our chair. So we are dynamically adding to our blueprint via the construction script during sort of like editor time. And this is pretty cool. This allows us to do this. And because we're adding it dynamically, there's a few things we can do to sort of push this further. If I just look in world, there it is. There's our chair. So one thing we might want to do is set the mesh. So this add static mesh component, we've got this thing here called a return value. So this is a reference to that object. So if we added the static mesh this way, the way we got references to that last time, we just dragged a copy in. And if you look, this is a static mesh component object reference. This is also a static mesh component object reference. So we can refer to things in the blueprint or the components in the blueprint directly if they're there. And if we're creating them dynamically, we get this return pin. And so what I'm going to do is pull off that, and I'm just going to do a set mesh command. Set static mesh here. And this is going to let us override what that mesh is. So we can set it here, we can set the chair. We don't have to. If we leave that as a default as nothing, it's just going to be a mesh with no, or a mesh component with no mesh in it. And then we're now going to set the mesh there. If we do that as sm chair and compile that, that's going to now set that chair to be back where it was. Don't need this. So this is really powerful. Now we're two separate components. We're adding the mesh and then we're also setting the mesh. But this can be something that we can promote to a variable. So if I set this and I just call this static mesh, I can now make this variable instance editable. If I just quickly compile that, we're adding a mesh, setting what the static mesh is via this variable, still this chair. Oh, that doesn't appear to have worked. Why has that not worked? That should give me a chair. It does. If I make this instance editable. Oh, excuse me, chair. Not sure what happened there. Maybe got a little bit confused with the compilation, but that should definitely work. And now if I go back to my viewport, if I take my chair, I can set whatever static mesh I want in here, and it's just going to set that on our mesh in our blueprint. Now this is basically a static mesh actor. It's just being able to set a static mesh. So it's not that useful, but we can take it a bit further. And what we're going to do, rather than just spawning a single static mesh, we're going to introduce this concept of a for loop. So if I bring this over and create a little bit of space in here, if I right click for loop, and it's not a for each loop, we'll get onto those later, but a for loop. And what this will do, it'll run our code as many times as we tell it to. And so we're going to plug our execution pin in first, and then we've got this thing loop body. So this is our loop, what it's going to do, how many times are we going to run this through, and then it's just going to keep running once, then twice, then 3 times, or as many times as we tell it. Now the way for loops count, they don't start at 1 and count up, they start at 0. This is a very common thing in programming, and we'll see why in a minute. But we want to set how many times this thing's going to go. So the first index is 0, and then the last index, I'm going to put this in just as 4 for now. And so I'm going to get 5 chairs, because 0, 2, 0, 1, 2, 3, 4, that's 5 chairs. So you start counting at 0, and then the last index is the number minus 1. So if I compile that and actually look at my viewport, it doesn't look like there's 5 chairs, because they're all exactly on top of each other. Well, it is doing 5 chairs, I can tell you that is true. And if I go in and actually select the blueprint, not going to appear as components here either. So you just have to take my word for it, there are 5 chairs there. Well, let's do something to them to make them visible. So rather than having them all at 0, 0, 0, all at local 0 in this blueprint, I'm going to add a little bit to my transform. So when I create my static mesh component, there's an option here for transform. If I just split this, so any kind of time you see well, most data types, you can right click, you can split them out into their components. So a transform is made of a location, a rotation, and a scale. And I'm also going to split out my location as well, because I'm just going to move my chairs across horizontally. And so I'm going to move them in this case, the y-axis. Now if I put a movement in here, let's say of 50, and compile this, my chairs have moved, but all 5 of them have moved, but that's not really what I want. What I want is them to move sequentially, and each one to move a little bit further than the one before. And luckily we have this thing here called the index. So we saw here first index, last index. This is a number that tells you how many loops you've done, or which loop are we on. So if I take this value and I multiply it, just using multiply here, int by float, this is an integer, you can't have half a loop, and we want a floating point value. And 50 looked a bit small, so maybe let's do 150, and I'll plug that into y. So what's going to happen? First loop we go through, we're going to have 0 multiplied by 150, well that's 0. Next loop we go through, now 150. Next one, 2, is going to be 300, 450, 600. And each one of our chairs is now going to get sequentially further and further away. So the number of chairs we have, in this case 5, are being offset. And this is where we count from 0. So you could start by counting from 1 and do 1 to 5. And it will compile, it'll cope with this. But now if we look, the origin, there is no chair at the origin. So generally we want to start our loops from 0 so that we get something happening on the 0th loop at the origin. So any offsets that we're doing don't apply until we get to that first chair, which is why we start with 0 and go up to 4. Just have a quick look in viewport, there it is, starts here, moves across. Pretty cool, pretty powerful. So a couple more things we want to do. Just sort of add some more functionality, more variation to this, or more controls to this I should say. So if we go back into our blueprint, this value here, I'm going to promote that, and I'm going to call it my offset y, and make that editable so that I can adjust that. And then also here, this last index, well, I'm going to promote that, and I'm going to call it, I can just sort this out, I'm going to call this one num meshes, and then make this instance editable as well. So now we'll be able to go into our blueprint in the world and adjust all of these values, and we can dynamically spawn a number of meshes at different offsets in the y-axis, which is pretty powerful. Now you might notice there's a bit of a mistake here. It works functionally, does exactly what we want it to do,
but there's a small issue in that the number of meshes is actually wrong for the number of meshes. So here we've got it's what's called an off by one error. Very common in programming. Whenever we're dealing with things that start at 0, we start counting with numbers physically at 1, but the programming way of doing it is starting to count at 0. So the number of meshes we've got here is different from the number of meshes we're actually seeing. Now maybe that doesn't matter. This number is never going to be exposed to the player or whatever it is you're doing, but it's also a very simple fix as well. So all we're going to do is take our number of meshes and then subtract 1 before we plug it into last index. And now if I say I want 5 chairs, 5 chairs is going to go from 0 to 4, and so that now will be correct. And if we jump back to world here, number of meshes 4, well, I can see that there were 4, and now we've got the correct thing happening here. Pretty cool. So let's take this a little bit further. So this initial setup is good. I like this, but let's say I wanted to do something to these later ones. So when the mesh is spawned, I get this reference, and then I can set the mesh there. This is all fine. But let's say something in gameplay happens and all of our meshes change. We want to set a new mesh, or we want to, I don't know, delete them, scale them, anything like that. Well, we haven't kept a reference in memory. We've used the reference when it was first spawned, but as soon as the next loop comes along, that's going to have disappeared because the reference wasn't stored. So we're going to introduce a new concept, which is going to be an array. So if I just take my return value here and I promote it, promote to variable, this is going to be set to be my, let's just say meshes. Let's not do it that way, let's just do it this way. So now this is setting that mesh, but then again, next time we go through the loop, this was connected at least, we're going to overwrite that mesh. We need some way of storing multiple references within the same variable, and we can do that. So because I've promoted, I've got the right variable type, but now I can delete this so that there's no reference to that variable anywhere, and I can change that variable type to be an array. And so you've got your variable type. So this is actually what the variable is. So this is the data type. And at the end, we've got here a single instance or single variable, an array, and then a set, and finally a map or dictionary. So we won't be dealing with sets or dictionaries. We'll be just dealing with an array. If we compile this, you see how here down in our default values, meshes, and we can add lots of instances of the same data type to this array. So we're going to create an array of meshes. And I'm going to call it mesh array, make it nice and clear. So I know the variable type was correct because I did it through promotion. If I'd promoted this and then tried to change the variable type, we're going to get this error here saying, are you sure you want to do this? Because it might break things in the future, or it might break things that you've already made. In this case, I know it's fine, so I can click change, and it's just going to search through all of our blueprints, which in this instance is very few, and just pick up if there are any errors. Much easier though to just make sure that when you're creating this and when you're changing that variable type, make sure you don't have any references to it anywhere, and then you can make that change without it having to complain at you. So how do we use this array? Well, in this case, we're going to go in and we're going to take our mesh array and we're going to add. We're going to add the output of our add static mesh components, and we're going to add it to this thing here that I've called mesh array. This link needs to go through there. This is fine. So now, if I compile this, just save, just have a look in the world. I've not exposed that parameter. We could do that just temporarily. We don't need access to this, but if we just expose it just to see. If I open this now, well, it's picked up a bunch of errors. If I move this, it's going to go through. It keeps adding new meshes to this array, but we can see we're getting those meshes added in. It's got a lot of errors in there. These last ones, node and static mesh. So these ones are to be deleted. Well, that's fine. If I just bring this in once, it's still got loads of errors. Why are you doing this to me? Here we are. But you can see it's adding lots of references to this mesh. If I turn off instance editability, it's now not going to keep adding those things. So we're only going to get the references to the meshes that we've that we've actually spawned through. And we can test that. So now I've got my my mesh being populated. So I've gone through, I've made my 4 chairs, I've got this data, and what I'm going to do, just on begin play, just going to put in a quick delay, let it load fully, and I'm going to use that for each loop. So this was the other type of for loop, and rather than happening a number of times, it's going to happen once for everything in the array. So in this case, if I load in a reference to the mesh array and plug that into my for each loop, this is going to have 4 chairs in it, or 5 chairs, whatever I've set it to be. And I'm just going to go through, and in this case, I'm just going to print. Let's do it this way. Print string, and it should just convert that name. Yeah, so it's just going to print the name of those 4 meshes or 5 meshes for me when I quit the game. So quit the game, begin play. Wait a second just to load in, and then it's going to run through those 5 meshes, 4 meshes, and we'll see if this works. So I'm bringing my mesh spawner, have a copy of this. I don't know if I'm going to turn it around so I can see the chairs, but I am. Now I've got 4 meshes in there. If I click play, 1 second later, there we are, I get my reference to those 4 chairs. That flashing's a bit annoying, let's get rid of you. So a for each loop will run through everything in the array, and the array is populated during the construction script. And if I make this longer, I have 8 meshes, obviously dynamically that array is going to get longer. My loop is now going to loop more times, and I'm going to get references to all 8 chairs, which is really cool, really powerful. So when you're doing lots of spawning, or using kind of like a generation script to create lots of a thing, you want to keep references to those later on that you can refer back to. The best way to do that is in an array, or often the best way to do that is in an array, and then we can get access to those things. So one last little thing we're going to do today, get rid of this. That was just a quick test. Maybe not get rid of it, maybe just do this and comment it out and move it up here. Remember, this is an infinite plane of code. Something like that, and we can come back and always hook it back up later. It's not doing anything if it's not connected, so there's no overheads to this. And I'm going to create a little loop. Now I'm going to delay for a second. Now we're going to just use this sort of delay loop as a proxy for gameplay code. Obviously when we're building a proper game, we're going to have other kind of interactions and things happening, but a nice little loop will work for us as an example. And then I'm going to get a value from that array. So mesh array, I want to just do a get a copy. And so I can access any individual entrant or entry, that's the word, from my array via a get. So before we did a loop for each loop, and this time I'm not going to do that. I'm just going to get a random mesh from inside my array. And so I need to know how long that array is. Well, I do know how long the array is because I've made it myself here via the number of meshes, but I can also dynamically use a length command. So the length of the array is how many items are in it. And in this case, like I say, it's going to be 5, or whatever my default was, 4. And I want to get one at random. So I'm going to do a random integer in range. Now, this would work, except for one thing. We've got another off by 1 error. So the length of the array is how many actual items there are. Well, that counts at 1 as a 1 item starts counting at 1. The random integer here, the index of the array, that starts counting at 0. So we need to have another -1 in here. Increment integer, 1 -1. So now, whenever we call this command, this node gets calculated, it's going to go through, find the number of meshes in the array. In this case, it would be 4. 4 minus 1 is 3, and it's going to create a random number between 0 and 3, and that's going to give me my random mesh. And what I'm going to do is I'm going to do a set scalar parameter value on materials. Now let's do vector. And we're going to randomly assign a color to the seats of our chairs. Now if I have my reference to my mesh here. This node here is set vector parameter value on material, so it's going to read that mesh, find the materials, and then find a vector parameter. And if I actually open up a copy of the chair material, let's go this way. I know that we have this parameter here called color seats, spelt the American way, but that's fine. We can copy that. So the parameter name that I want is color seats, and the parameter value, I'm just going to do a random, and I'm going to do a random unit vector. So this is going to be a random direction or a random color, and it's going to set on one of my random chairs. Now, this happens after a second delay, then I want it to loop. And the way we did that before was to go in and sort of drag that pin round, and that works, that's fine. Nothing wrong with that as a sort of loop. And let's just test it. Let's try that as for now and see whether that works. Here we are. So every second we get another random color on one of our chair seats. Pretty cool. Pretty cool. So either using for each loop to create everything to sort of access everything in an array, or just using here where I'm using a get random value. And obviously if you've stored something very specific in index 2 and you know that that's the thing you want to access, you can just get that directly as well. But one last thing I wanted to do. Now this loop works, we've just shown that. But what happens if we've written loads and loads of code? We don't really want to have to like drag this back. We want to jump around directly. So we're going to introduce one new concept for today, and that's going to be what's called a custom event. Now we've used begin play. We used begin play. We talked about event tick. So any of these things are events. So these are ones that are built into the engine and can just be called via code via the engine. But we can also build our own custom events. And this one's, I've just named it loop color swap, and it's going to go around and it's going to happen before the delay. And so begin play is going to happen once on startup, and then we can also call this event from anywhere else in our blueprint, or in fact from other blueprints. And so you can build up kind of events and logic across multiple blueprints. And the way we do that is now I've created that event, I can just access it via the normal way as a node. And so this is the calling of this event. And if I just click play, I can actually just watch it in the debug. And so every second it hits here and it loops back to there. So it's the exact same as we had with the two reroute nodes. But now we're not tied to having a small loop. We can go off and put as much code as we like in there, and we can call functions between different things. And if we look in world, we'll see that's still working, and we're still getting our chairs randomly changing color every second. Cool. So a few key takeaways from today. Firstly, we can dynamically add things to our blueprint at runtime, either construction script or through gameplay. If we do, we probably want to keep a reference to it. And so if it's just a single thing, fine, we just create a variable and set that. But if we're adding multiples, we probably want to use an array. And then once we are using arrays, we can either access everything in the array via a for each loop, or we can just access an individual item, in this case at random, using the random integer based on the length of the array. Pretty cool stuff. Right, that feels like enough for one lesson. As always, if you have any questions or comments or anything, let me know. Big thanks to everyone supporting the channel, especially my patrons, and I'll see you all next time for some more blueprints.